Hello everyone, welcome back to Math with Mitchell. And today we're going to be going over factoring polynomials. This is a very useful method, FOIL method, that we'll cover today for factoring polynomials of degree 2. So degree 2 means that x is raised to the second power. And now this video is not going to go over why factoring is useful and what the applications are for factoring are why it's used, but it's going to go over how to actually factor a polynomial. In later videos we'll cover why this is useful, but it's a very important skill to use, and there's many applications, and you'll be using it through all of your math classes in the future. And so first, why do we, or what's being factored? And it's really splitting up or combining. You're either combining these two linear equations because it has x to the 1, so what we call a linear equation, or it's splitting up an x to the 2 or quadratic equation. So it's just getting it into simplest forms, and depending on the problem, you either want to simplify it, which would be simplifying it to two linear terms, or two roots, or two zeros, or you want to combine them in order to get one quadratic equation. So it depends on what you're looking for, but the method to solve them is basically the same. You just reverse it or actually do the method. So the method is called FOIL, which stands for first, outer, inner, last, which is sort of an acronym to remember what steps to do and what to multiply together. So if we were combining these two linear roots to get a quadratic equation, according to the FOIL method, we will multiply, because you're multiplying each of these steps. Multiplying the first term in each, which is going to be the x and the x, to get x squared. Then you want to multiply the outer by the outer of the other one. So the outer of this one is going to be this term here, because this is farthest away. Sorry about that. This is going to be the outer on this term, because that's going to be the farthest away from this term, from this linear equation. And this is going to be the outer on that term. So you're going to multiply these two together to get plus 2x. And then inner. So you're going to multiply the inner term relative to the other linear equation and the inner term here to get minus 5x. Now you might recognize that these can be combined, but we'll get to that later. Then you're going to do the last, which is going to be the last term here and the last term here relative. So that's going to be negative 5 times 2. Sorry, I sort of covered it up, but it's going to be negative 10. So then you combine like terms, as you probably noticed earlier, and you get x squared minus 3x minus 10. So that is your quadratic equation that is equal to these two roots, which is kind of a unique thing, and we'll use that for a lot of different applications in the future. Now, what if we had the opposite? What if we had the quadratic equation, but we wanted to find the roots, which is, you'll probably do that more often than not, is take a quadratic equation like this and factor it out into two different roots. Which, for that, there's a lot of different techniques, but you're basically using the same principles that are in the FOIL method. So you're splitting it into two linear equations. Now, you know that usually what I like to do is I like to take this first term here and figure out multiples of that term. So since this is just a 1x, you know that the first term is going to be an x and this term is going to be an x. From there, I want to find multiples of this that will add up to get this. Like in our earlier equation here, 2 and 5 are both multiple factors of 10. They multiply to equal 10. But they also add to get negative 3. So we got to find that balance. So what would that balance be? Well, 9 has factors of 1, 3, and 9. So I think 1 times 9 is not going to give us, is either plus or minus 7, or is either going to equal 8 or is going to equal 10, which we have a 6 here, so that's probably not going to work. So we have 3, which 3 times 3 equals 9. And since we're looking for a plus sign and a minus 6, we can do maybe something like minus 3 minus 3. Because minus 3, or negative 3 times negative 3 is going to equal plus 9, but negative 3 plus negative 3 is going to equal negative 6. So those are our two linear equations or roots that will work for this quadratic equation. Now, I'm going to go in a little bit more in depth in why these are roots, why we call them roots and zeros and solutions and like that. You'll be covering a lot of this throughout high school, but it's important to know that this is a nice little application of it. So if we have a quadratic equation, it sort of looks like this if you graph it. This quadratic equation here on a graph is going to be equal to, or is represented by these intersections, right, across the x-axis, which we'll be covering a lot more of this detail, but it's kind of a cool application. These roots, if we do x minus 3 equals 0, bring over the 3 so that x equals 3, then we know that there's a root here at 3. So this would be 3. We know that the quadratic equation touches the axis at 3. Touches the little thing. Now sometimes you'll see this simplified since they're both the same linear equation. You'll see x minus 3 squared. So that's the FOIL method. It's very useful in thinking about how to split up or multiply together two roots to get a quadratic, or taking apart a quadratic and getting two roots.